Right. Today we are going to discuss about basically the searching and sorting algorithms. Searching and sorting algorithms. Basically, so we have already learned the basic about Python programming. So where in Python programming, we discuss about tree control structures. In these tree control structures, we learn sequence, selection, and repetition. Sequence, selection, and repetition. That's what we have learned in this basic programming, right? Sequence, selection, and repetition. Those are the tree control structures. And as a summary, so now we know these things. So let me summarize. So if you don't know these things, I'll help you. Don't worry, I'll help you. In case if you miss this, I'll help you remind these things, but I can send you the videos of those we have done. So basically, so we know about the operators. So there are few kind of operators: arithmetic, logical, comparison, then bitwise, arithmetic, logical, comparison, bitwise, assignment. So these are the operator types that we have learned. And in the control structures, so we learn about tree control structures. So we learn about sequence, where the instructions are executed one after another. Selection, basically if else, within bracket I can say if else. And then repetition. So basically we learn loops, for loop, while loop, we learn those things in the repetition control structure. Then we learn about the functions. Under functions, we have discussed about a returning function, non-returning functions, recursive functions. Then about file handling. These are the main topics, right? File handling. Then we learn about reading, writing, and appending. That is also for both binary and text files. Now we have come to a stage where we have to discuss about searching and sorting algorithms. So please write down the heading: searching and sorting algorithms. And this is the new topic today. Actually, instead of running the code, instead of identifying the code, let me explain this just using some illustration tools or just using some animations, right? Searching and sorting. So algorithms, basically, we need to, when we need to search a file, when you need to search database or search for a record, so we need to do that in few methods. So the easiest way is sequential search. Easiest method is sequential search. Okay, that I'll explain using an example. So let me take IDLE. So you can also download IDLE, so to write the codes. And if not, you can use the Python online compiler that is also working. You can use Python. So this is immediate solution, right? Online compiler, and there's a compiler called GDB compiler, this online GDB. So that is also okay. So either one of these you can use. Okay, let's use GDB compiler, this online one. And I'm going to have a small list. Let's say I have a list of items. Marks. Marks is a list. And I have a list of items where marks. These are different marks related to some students. And I just need to search some element of in this. I just need to search some element. Okay, the easiest way is go through each and every element. Hamma element ekakma apita check karanna. Okay, let's say input, and I'm going to take, okay, let's say x equal int input. I'm going to search an int. Purna sankhyaවක් තමයි මම search කරන්න යන්නේ. int input, enter, and enter a number. to search. I'm going to get that number. And I'm going to check that number in my list. Okay, let's run this. And okay, it will ask me a question, enter a number. Let's say I want to search 45. So nothing happens because still I didn't write any algorithm. Without even algorithm, you can search. Then you may wonder why we need an algorithm. Algorithm ekak nathuwa search karanna puluwan because Python there's an operator called membership operator. Actually, I could mention it here, sorry. There is an operator called membership operator. In this membership operator, it's very easy. I can check if X in marks. See how easy this is? If X in marks, I can say print. Let's say X, comma, found. I found X. Well, let's run it. So I'm searching 45 and it says 45 found. You can see it's 45 is there. Let me run it again. So I'm searching for 100. It says nothing because it's not found. Or you can use this else part, right? Else print not found, right? Or you can say another if is also okay. Okay, let's run this and I'm sure not sure. 34 not found. 34, is it not there? No, it's not there. So let me run another one. I'm searching for 66. It's not there, so it says 66 not found. Searching for some other number, 100. 100 not found. Let's search for a number which is existing, 67. 67. It says 67 found. Okay, this is easy. This is not an algorithm. So this is just an operator. Membership operator කියන්නේ මේවට තියනවාද කියලා බලන්න පුළුවන්. මේ marks list එකේ you can check the mark list and check whether X is there in this mark list. X තියනවාද මේ mark list එකේ. This is simple. But this you don't write this in your examination, right? This is not an algorithm. මේ algorithm එකක් නෙවෙයි. Because this is already developed code segment in the coding. ඉතින් එහෙමනම් ඇයි අපි algorithm එකක් ලියන්නේ? So since we have a method of finding that easier, so why do we need to write another method? Because we need to understand the underlying theory of these operators. That's why we write an algorithm. We want to write algorithms and explore this. එහෙම නැතුව මේවා කරන්න ලේසි විදි තියෙනවා. For an example, think about sorting today. Sorting means like ordering these marks. So simplest way of sorting is you can write okay, let's print this marks and you can sort it. So see how simple these things are. නිකම්ම sort කරන්න පුළුවන්. හැබැයි sorting algorithm ඉගෙන ගන්න වෙනවා. Okay, let's search for 68. It says 68 not found and you're sorting. Okay, after that you can print this marks, right? Sorry, marks.sort, and after that you can print the marks. That is print marks. That is better. Okay, let's search for 67. It says 67 found and you can see the sorted list. So it's only one line code. Marks.sort is only one line code. But we are not going to write this in the examination. Exam එකේ මේක ලියන්න බෑ. මොකද එහෙම එකක් නෙවෙයි exam එකේ. And in the examination they will ask an algorithm to search, not a method. This is a method. This method is capable of sorting. This method is capable of searching. Right? But in the examination, it's asking algorithm for search and algorithm for sort. So let me comment. I'll write as a comment. Method for searching using membership operators. Method for searching using membership operators. And this is method for sorting using sort function. First of all, please write down this method for sorting using sort function. We write down the heading, search in and sort in algorithms. Search in and sort in algorithms. So this is the heading. Under that heading, please write down this code and explain there are methods. So before that, we will need to write small note for this heading. In Python, there are easy methods for searching and sorting. In this section, we will not use such methods, but we will try to develop an algorithm or step-by-step solution to solve sorting and searching issues. Okay, please write down this part. Lazy ක්‍රම තියෙනවා. හැබැයි lazy එක නෙවෙයි මේකෙදී අපි ඉගෙන ගන්න. අපි හදන්නේ ක්‍රමවේදයක්. We are going to build a system or mechanism or an algorithm to solve these sorting searching problems. First of all, write down this code. You can try this even, right? You can try this using Python online compiler. So I'll send you the link. If you don't have Python ideally in your computer, you can try with this online compiler. But if you have Python ideally, you can try that in Python ideally too. So to do that, you have to go to File New, take a new Python file, then write down code over there. Sorry, not that. Let's write down this code. Then just run it after saving. Either way, you can use. Say feb 12 al.py. Enter number to search, let's say 66, and it's not found. It's giving the sorted list, right? Okay, please do this quickly. Write it and also show this. Also, if you can try this, then I'll teach you the algorithm part. Algorithm part. Okay, please write down this quickly. Okay, let's move for the searching algorithm now. What is an algorithm? So searching is easy. So the first one that we are going to explore is sequential search. Sequential search. In this search method, in sequential search, please write down the subheading, sequential search. So here in this method, we are going to check item by item. Okay, let's go to method number 1. There are many methods of implementing this. Method number 1, you can check for item in marks. So very simple. You can check if search item is X, no? If X is equal to item, then you can say, hey, I found the item. Print X found. Simple as that. Okay, so let me run this now. Actually, before running this, I would like to temporarily stop these codings. I don't need these things, so I'll cut it. Save. So, okay, it's now asking enter number to search. I'm going to search 44 and it says nothing because 44 cannot be found. So let's run it again, and I'm searching for 46 now and see 46 found. Okay, let's search for 56. Running and searching 56. And it says 2 times 56 found. So even it is found multiple times, it let us know. So this is sequential search. So very simple. You go and search item by item, and once the item found, you display is found. Okay, sequential search, then method number 1, please write down. item by item, you just compare. So this is method number 1. This part I can keep. So let's comment everything, right? Otherwise, like that will also be executed now. Okay, this is the, and also you can search by item index. There's another way, no, method 2. You can search by item index. You can say for item in range, length of marks. Then it will execute. Then you can say if X is equal to marks, the particular item. That is also a valid way of finding an item. So let's run this. Let's run this, and I'm going to search for 45. It says 45 found, 45 found. And the second time also 45, 45. This is second method, right? So let me write down the method name, print method 2. The first method is searching using the item. The second method is using, second method is basically using the key. The first method is just using the item. The second method is using the key, right? Key. It's index. This is item. Item එකෙන් තමයි පළවෙනි එකේ. දෙවෙනි එකේ index එකෙන්. බිංදු වෙනින්ද කී වෙනින්ද ඒක හම්බුන තැනක් කියන්න පුළුවන්. And in, you can say the place. Place is item in, you can say in place. Then you can tell the item. So what will happen in the second method? Okay, let's search for 45 again. Okay, you can see item and the found place. The first place is also, first place means, where's the first place? 0, මෙයා තමයි first place. 0 වලින් පටන් ගන්න 0 first place එකේ හම්බුණා කියනවා. It was a 1, 2, 2, 3, 4, 5, 6 place එකේ හම්බුණා කියනවා. And you can add 1 and show this with the proper one, right? Otherwise, the indexes are starting from 0. May 0th item එක list එකේ 0, 1, 2 කියලා තමයි යන්නේ. 0, 1, 2. අපි එකක් එකතු කරගත්තොත් මෙතන එතකොට 1, 2 කියලා එනවා. 1, 2. එතකොට දෙවනි තැනක් තියෙනවා 3, 4, 5, 6, 7th තැනක් තියෙනවා. ඒ තැනත් හොයා ගන්න පුළුවන්. Let's run this now. I'm searching for 45. And it found in the second and 7th places of the list. Second and 7th places of the list. Okay, let's search for some of the. Let's search for 90. Item 90, which is in the last place. Okay, 90 found, and 90 found in the place 11. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, yeah, 11th place. It's found in the 11th place. Okay, there are a number of other ways to do this, right? Even you can use the for loop. Method 3, you can use the for loop. For loop, not for loop, the while loop. When you're using while loop, you can say, let's say k equal 1 or k equal 0 while k less than or equal to or k less than length of marks. You are going to repeat this with the x equal marks k. X is the item, right? X is the item. X equal marks k, and then print found, and this should be k plus 1, right? That is method number 3. Okay, now let's run that. I'm searching for 90, and the first one is saying, okay, second one, third one has a problem. Sorry, I have to increase this because while loop, no, I have to increase this after each round, k equal k plus 1. Otherwise, it will not go to the next item. Now let's try. I need to find item 90. My method number 1 says it found, method number 2 says found in the 11th place, and method number 3 also says found in the 11th place. Okay, you can just copy and try this, Pute. If anything difficult, please ask. For loop එකෙන් කොහොමත් එක ගාන යන එක වෙනවා. මේ while loop එකෙන් අපි කරන්නේ බලෙන් එක ගාන යවනවා ඉස්සරහට. We are stepping into 1 1 1, but anyway for loop will go 1 by 1. That is by default. But while loop you have to start and you have to tell the step in by 1 by 1 by 1. Then the item found, it says found. So for loop, while loop, any loop, even repeat until or the true while loop, anything can be used to write this algorithm, sequential search. It is very, very easy algorithm. Write and tell me once you are done, right? Write and tell me once you're done. Sequential search. Sequential search. So another name for sequential search is linear search. Linear search or binary. So I'll explain both. So let's say I need to search for 34. I'm linear searching. It's check-in with each item. You can see the animation, right? It's check-in with each item. When I search first one, second one, and it keeps searching, right? It keeps searching the item until it found. So let's say first, second, and 34 search in index here. I have to give the index also. Let's give it's not going to the further indexes. Just wait. 15 indexes. Let's search for some other item. It's only searching one index, right? It's found. So let's search for some other element. 34. 1, 2, 3. You can see item by item, it's just comparing and moving, right? Item by item, it's comparing and moving. Actually, this list is already sorted. So this list is already sorted. So after 38, it will stop searching. Why it is stop this searching? The reason is because after 38, you won't get 34, right? This attempt because this list is already sorted. Here, search in a sorted list. Search in a sorted list. So since this list is already sorted, it won't search after 38 because 38 is bigger than 34. Then after that, you won't get that. Well, let's search for a large number. Let's search for 700. And in the linear search, it's comparing, starting from the beginning, and it's going 1 by 1 by 1. So keep this animation in your mind. Searching 1 by 1 by 1. Keep on increasing and searching for the item. This is what happened. In the worst case scenario, right? In the worst case scenario, this can go up to 179. That means number of items. Altogether, there are a lot of items here, closer to 179 and 180 items in the list. So it's keep on searching. And 700, so in order to search 700, it should come to here. So you can see it's keep on searching the item. That is called the sequential or linear search. Another name for sequential search is linear search. Okay, you can see it's keep on moving 1 by 1. This is okay for unsorted list also. Unsorted list not make a prashna because it can compare the items, but unsorted list, it will search until the last item, right? The sorted එකක නම් මේ 700 පැනපු හැටි නවත්තන්න පුළුවන්. එතනින් එහාට 700 නෑනේ. After 700, so no need to search. You can stop from here. 700 හම්බුනේ නැත්නම් මෙතන 118 වෙනි ඉන්ඩෙක්ස් එකෙන් නවත්තන්න පුළුවන්. මොකද එතනින් එහාට ආයි 700ක් හම්බ වෙන්නේ නැහැ. Okay, let it go. Okay, search in and okay, you can see it's element not found. Element not found because after that you cannot find. Right? Element not found. So the worst case is it can go up to the last item. In the binary search, this will be efficient. Binary search එකේදී මේක මීට වැඩි efficient. It will start from the middle. The first item is 0. The last item is 179. So the middle item will be so altogether 180 divided by 2 is 90. 90 will be the middle item. It's starting searching here. It will start searching from here. 90th item. So if you are searching 700, 700 is more than 90, this item, right? 90th item. So it will go to the right side. So it will initially jump into the middle. See, so let's binary search. Okay, it will take the total and go to the middle item. Then again, go to the middle item. Again, go to the middle item. And again, go to the middle item. And search is now over. Okay, not found. So this is extremely fast. This is extremely fast. Let me slow down again. So let's search it again. I'm searching. එයා කරන්නේ පළවෙනි item එක ගන්නවා. අන්තිම එක ගන්නවා. දෙක ඒක දෙකෙන් බෙදුවම එනවා 89. 89 වෙනි එක බලනවා. ඒකට දකුණු අත පැත්තේ. ඒකෙත් පළවෙනි එක ගන්නවා. අන්තිම එක ගන්නවා. ඒකේ මැද්දේ 134. ඊට පස්සේ 134ට එනවා. ඊට පස්සේ ඒකෙත් මැද්ද එනවා 133යි. So then again the middle of that. ඔය විදියට හැම වෙලේම search කරන්න ඕන එක භාගයක් වෙනවා. This is called binary search. Okay, I'll use a small list, right? So make it easier to understand. Let me use small list, right? And in this small list, I'm searching for 224. 224. In binary search. මෙතන ගත්තා අන්තිම එක ගත්තා. ඒකේ මැද්ද තමයි 15. හරි? ඊට පස්සේ 15න් අඩු එක 14 සහ මේ පැත්තේ ගන්නවා 14න් භාගේ 7 7 වෙනි item එක. ඒක තියෙනවා. So you can see it found. So how easy to search? Okay, let's search for 284. 284 binary search. 0 last. Then the middle will be 15. Need to search 284 in the lower part. Therefore 14, then middle is 7, and then move into the 8. Mid is 11, move into the mid. Then mid is 12, and mid is 300, move in there, and then you can see it's found. So this is how the binary search happens. Right? Okay, so let's understand this carefully. So searching and searching algorithm, the first search is sequential search. Right? Sequential search. Right. Please write down on that. In sequential search or linear search, sequential or linear search, linear search. Sorted or unsorted list of items are accessed in order from the beginning to the end. In the best case, the item can be found in the first index. In the worst case, the item cannot be found and the algorithm will access all the elements of the list. Therefore, the complexity of this algorithm is mentioned as ON. So please make this NO little bigger. मैं O एक लोकु करला लिया. Mentioned as ON. O, big O, notation is indicating the worst case scenario. If item is not found, it will search n items, and n is equal to number of items in the list. It will search for all the items. It will search for all the items. තිබ්බේ නැත්නම් පළවෙනි එකේ ඉඳන් 1 2 3 විදිහට අන්තිම item වෙනක නම්ම search කරගෙන යනවා. Okay, the next search is binary search. Okay, please write down this, then I'll do the note. This big O notation is put there. Big O notation is actually a notation which is used to measure the complexity. Complexity means how expensive the algorithm is. Expensiveness is basically how many searches or how many comparisons it does. So here actually it will compare n number of items. Let's say in this example, so let's say in the sequential linear search, let's say your item is 1000. You are going to linear search this 1000, but it will search one by one and go up to 31st items. Item 32ම බලනවා මේ. එකින් එක ගිහිල්ලා 32 දක්වාම තිබ්බත් නැතත් බලනවා. So the algorithm is basically searching up to n. This is n. Let's say n items. N items තියෙනවා නම් item n ප්‍රමාණයක් මෙයා compare කරලා තමයි නවත්තන්නේ. Even though it is there or not there, it will search from the beginning to the end. මුල සිට අග දක්වාම. Then the worst case is it will search n items. So that is called big O notation. Big O notation කියලා ලියන්නේ ඒක. එකෙන් කියන්නේ මේකේ worst case එකේදී කොච්චර search කරනවද? In this case පුතේ it will search 32 items. You can see it's keep increasing and it will search 32 items. ඒ ඔක්කොම ගිහිල්ලා ඉවරලා තමයි ආ කියන්නේ. After searching all 32 items, it says after searching all 32 items, it says the item is not there. That is in the sequential search. But binary search is a bit different. Binary search එකේදී මේක මීට වැඩිය වෙනස්. Okay, let's develop an algorithm, then only you will understand what binary search is. Hari, binary search එකක් අපි කරනවා කියලා හිතමුකෝ. Let's make it smaller and let's do a binary search, right? I'm going to do binary search for 1000. No need to do 1000, let's say search for 500. එතකොට in binary search, this is the algorithm. So see here, low is 0, high is 31. Here, low is 0, high is 31. Low 0, high 31. Then it will take the middle value. 0 plus 31 is 31. Divide by 2 is 15.5. So it will come to the 15th item. So it will start searching from the middle. Yeah, 15 එකෙන් තමයි පටන් ගන්න. Okay, let's just step forward. Here you can see the middle value is 15. There are 15 වලට වැඩි. It will compare. My search item is 500. So 15th item is 3,347. Is 500 less than or greater than? Is 500 less than 347 or is it greater than? Guys, are you there?
Greater.
Greater than, yes, it is greater than. Then, is there any use of search in this part? May part එක search කළා වැඩක් තියනවද එන? It's useless, right? Because 500 is greater than. එහෙනම් මේ අඩු කෑල්ලේ නෑනේ, මේ පැත්තේ 500 නෑනේ. Then this part you can skip. So next you start searching from this item. එහෙම අතෑරලා යා මෙතන ඉඳන් search කරන්න ගන්නවා. යා search කරන්න ගන්නේ දැන් මෙතන. මේක තමයි දැන් යාගේ first item. Okay, you can see then the next step, ඊළඟ step එකේදී here step forward, step forward, step forward. You can see now the low item, the first item will be 60. And what about the high item? The high item will be 31, sorry, high item will be 31. Then the mid item is, you have to divide by, so the high item, low item and the mid item. 31 minus 16 is 15, sorry, 31, you have to divide, sorry, add both numbers and divide it, right? So 31 plus this is like 47, 47 divided by 2 is it correct? So let's take the calculator. My calculation ability has gone down. Okay, the low is 16, high is 31, altogether 47 divided by 2. It is 23, yeah, 23. Then the 23rd item. So 505. Is 500 less than 505 or greater than 505? Is 500 less than 505 or greater than 505?
Less than.
Less than. If it is less than, Pute, then greater than search kala wadanne nane. You ignore this part. You don't want to search this. Another half of the list is cut down. Now you are searching only this part. Now making, in this case, the next value will be in between value 16 plus 23. Then the center value will be, you are searching your search item, is this equal or less than? So then the less than comes, then select the left tree, left side, right? Then the item will become, okay, not this. This is the list item, 16 plus 22, divide by 2. Divide by 2. Divide by 2 will be 19 here. Yeah. It will come to the middle. The 19th item is 409. So then 500 is greater than 409. 500 is greater than 409. Then it will ignore the left part and then, okay, left part එක අතෑරලා ඊළඟ එක set කරගන්න. It will ignore this part, no need to search here. The next will be this. So 20, 22. 20 and 22. The middle one will be 21. You just search 500. 500 is greater than 434. Then this part will also be ignored. And only remaining item will be this. You compare with this and that is not, so result is negative here, not found. Try to understand, okay? You're getting this. Then the middle value. After middle value, you just compare the middle value with this one. Okay, not equal. If middle value not equal, then step forward. You are taking the next value, that is this only one value now. You have to compare this value with this. And if not, you have to tell not found. 22 is the middle. You are searching the middle value and that is not equal. So ultimately you can tell not found. Okay, no need to move forward actually. Result is not found. That is it. Okay, I hope you understood the binary search algorithm, right? So this is bit complex. Can we apply binary search for unsorted list? Sort කරපු නැති එකට පුළුවන් binary search දාන්න. It's not possible because we don't know the values left side and right side. The left right value දන්නේ නැහැ කියන්නේ sort කරපු නැති එකට අපිට binary search දාන්න බෑ. Okay, පුතේ. Please write down this. Binary search. So please write down binary search can only be applied to binary search can only be applied to a sorted list. Binary search can only be applied to sorted list. Okay, so let's write down the algorithm. This will divide the list into two parts. First item and the last item will be added and the center item will be discovered by dividing the total by 2. Comparison is done only for the center item. If the search item is more than the center item, then the left side of the list will be ignored. If the search item is less than the center item, then the right side of the list will be ignored. This process is repeated until the list is traversed or until the list is traversed or list is over or until the search item discovered. So I'll apply the same algorithm which is mentioned here over there. So this is actually a clear one. Can just write this, I think. Okay, under that, please write down this, and under that, please write the complexity of binary search is only log n. Therefore, it is written as big O log n algorithm. So therefore, it's written as big O log n. So this big O notation, they won't ask today. So I'm just telling this is bit advanced. Sometimes in the examination, they won't ask about the big O notation. Why it is log n? Because it is not n, it is logarithmic. Logarithmic කියන්නේ n එකෙන් භාගේ ඒකෙන් භාගේ ඒකෙන් භාගේ. ඒ කියන්නේ n එක 100,000ක් නම් මුලින්ම සර්ච් කරන්නේ 500. ඒ 500 නුත් මැද්දේ නැත්තම් 250යි. ඒකෙන් 125. එහෙම භාගේ වෙලා ඉවර වෙනවා ඉක්මනට. So it is log n algorithm. It's fast, but only for a sorted list. Sorted list එකට විතරයි ඔක තමයි අවාසි. Sorted list එකට විතරයි ඔක කරන්න. Let's compare both linear search and this binary search, right? I'm going to define a function. Okay, that is linear search. This first one is linear search. So let me write a function def, let's say linear search or sequential search. In sequential search algorithm, I'm going to give the list, data, and search value. What it's going to do is basically use one of these loops. Let's say it's very simple. Using one of these, if the item or the value for item in the list data, so if value equal to the item, it says found, else you can say print not found, not found. Not found, right? Okay, this is sequential search. So let me comment other things. This can easily be done by adding triple single quotation. Sorry, here. 1, 2, 3. Let's finish it here. Okay, this is a sequential search, and you have list and also this. Then the sequential search can be applied. And how many searches? You can count the number of searches. Let's add a counter to see this. C equals 0. Initially, the counter will be 0. For each comparison item, I'm going to see C equals C plus 1. And finally, after all these things, let me see, print the counter. Searched. Okay, print. Searched. Then C times. Okay, let me show the meaning of this code. Let's run this. And I'm going to search item let's say 45. And then I'm going to apply the sequential search. Sequential search. Sequential search, then the list data you already given, that is what is this marks. And you need to search for item X. Okay, initially you can say not found, but second time search 2 times, found and not found, not found, not found, not likewise it's going 45, not found, not found, here also found, right? It's listing all the items, but no need to print like this. That is headache. So no need to print like this. Once it is found, you can say return 1, else you can say return -1, right? Otherwise, like once it is found, you can return 1, and after that you can terminate this break. So if not, you just return -1. Else, if it is found, return 1. If not, you're going to return -1. Okay, let's run this now. Searching for 45. Says minus. Sorry. If it is found, then my 1 break. 1 and break, else. Oh, sorry. This is, I have to avoid this number of times that I have searched, that I have to avoid. Let's avoid that and avoid this as well. If item in for yes, for item in list, if value is equal item, then return 1 and break. If item equal the value, 1 and break. Else you can return -1. If not found, return -1. But here actually in each item, so even though once it is found, and is it breaking? Let's say, is it breaking after finding the value? I just want to check. Return 1 and print found and break. Let's search. Sequential search says -1. Something wrong here. Once the item is found, so item is value equal to the item, value equal the item. Value is this one. Are we going to search for 45? Yeah, still it says the list data and list data. What is list data? Marks. It is also correct. Okay, let's write it here, Buddhi. Then write in this marks and X. Marks and X. X is this, and marks, you know, we have obtained that in the earlier stage. Let's write down here. Now let's search. Enter number to search. All right, now only it's work, otherwise like it's wrong. Enter number to search, and we were searching 45. It returns nothing, right? It returns nothing. Okay, we can say result equal to this one, and finally print the result. Okay, let's see this now. 45 I need to search, and it says -1. Means not found. Is it not found or found? 45 is there. So it says, it should say found. it should say found. Value is this one. That is this X that we are going to feed. X is the value, okay. And item is for item in list. Value equal item, then return one. I'm getting an error. Can you help me? So why is that? So list data is there. Okay, that is this list. Value is there. That is this value. That is X. That is 45 here. I'm searching for sequential search. Yes, that is also there. Okay, let's stop breaking this and just want to print this whether it's found or not. Okay, 45. Still I'm getting -1. Okay, let's stop the returning. Print. Not found. Something wrong in my code. I'm sorry. Still I cannot find that. Okay, it's running. Not found. The first time it is not found. The second time found. Okay, this is working. Only thing is that right. Only thing is that so each time it's trying to return either -1 or 1. So that is the reason. Each time it's trying to return either -1 or. So to stop that, actually we can do something. We can keep a variable called found equal false. Found equal false. And here, once it is found, we can say found equal true. Right, found equal true in case if it found. Finally, without anything, we can return found, right? Return found. Well, let's see this now. Now I'm printing this. And now I should get the answer. Sorry, I did a mistake. And now I have corrected. 45, you can say it's true. It's there. Searching again. This time I'm searching for non-existing item 100. You can say it's false. Okay, searching again. And this is existing item. I'm searching for 90. It says true. True means found. Okay, searching again. Then 47 false. Yeah, 47 is not there. Yes. So it is finding that. And number of times that it's going to navigate, I can count by using this counter. C equals 0 initially. When we start, C is 0, but any number of times it's counting the C equals C plus 1. And here actually after returning this, before returning this, you need to tell how many times you searched. Print searched C times. Okay, now let's see. Let's run this. I'm searching for 47. It says search 12 times. Search 12 times and return false. Still couldn't find search 12 times. And let's run it again. And I'm searching for existing item, which is 90. It says search 12 times and return it. So whether or not it found, it goes 12 times. That is bad algorithm. කියන හම්බුණත් 12ක් search කරනවා. item 12යි නේ තියෙන්නේ. හම්බුණත් 12ක්. දැන් 45 වගේ එකක් බලමු. Let's search for 45. So searching for 45, still it's searching 12 times. That is bad. It should stop when the item found. It should stop. To do that, I can break. Okay. Let's run this. 45. Now you can see it's only finding 2 times. Because once the item found, it breaks. So no need to search. 45 දෙවනි තැන හම්බුණා කියන්නේ ආයෙ search කරන්න ඕනේ. Search 2 times. Okay, let's search for 90. Run. Then I'm searching for 90 this time. You can say search 11 times. 11th item is 90. I'm searching for 47 now. Okay, 67. Let's search for 67. run module. I'm searching for 67 and it says search 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 times. Now it is stopping. Now my algorithm is good because once found, it stops. Once found, it breaks. Once found, it stops. So this is proper algorithm for sequential search. Now you can copy that and let's write the binary search after this. Okay, first of all, please copy the sequential search function. This is a function, right? For the sequential search, this is a function. Earlier we did sequential search, that is true, but it was not non-optimized algorithm. Non-optimized algorithm කියලා කියන්නේ ඒක නවතින්නේ නැහැ. හම්බුණත් නැතත් 12 පාරක් search කරනවාමයි. Loop එක ලියලා තියෙනද 12 පාරක් යනවාමයි. It is non-optimized algorithm. But this one is optimized algorithm. Once found, it will stop. 23 වගේ එකක් නම් search කරන්නෙම නැහැ. පළවෙනි එකේම හම්බෙනවා. That is called best case. Let's search for 23. The best case is the first one is found. So let's search for some non-existing number. Mama search කරනවා 800 ඒක ඇත්තේ නැහැ. Then it will search 12 times. That is worst case. So this is best case. Best case කියන්නේ මේකට. This is worst case. ඇත්තේ නැතුව හැමතැනම search කරනවා. This is worst case and this is best case. Okay. Please write down this and then let's move to the other algorithm, which is binary search. But remember that for the binary search, you need a sorted list. For non-sorted list, binary search will not work. Therefore, if you need to apply binary search, you have to first sort this. Sorting algorithm still we didn't learn. So our plan is to learn that next week. Okay, please copy this. Okay. To compare algorithms. So I'm going to implement the second algorithm, which is this one, right? So just implement def binary search. And same parameters can be passed. But here you have the low value and low value 0. Then high value is actually the length of the particular list. Length of the list data and -1. So not the length, because length is this is 0 based indexing, right? 0 1 2 3 කියලා නියන්න index. ඒතකොට item 4ක් තියෙනවනේ 0 1 2 3. හතරවෙනි item කියලා එකක් නැහැ. It's third item, right? No item called fourth item. 0 1 2 3 starting from 0. That's why -1 comes here. Then while you can say while low less than the high. So low less than high means still it's not interchanged. Low less than high means something like this. Okay, let's say you have a list. So low less than high comes when the search is over and only 2 items left. Then the low goes this side. That means in blue එක high now. If blue is high and low is 22, after searching, after all the searches, 22 will go to the right side, which is 24. Or where 22 will intersect with 23. Then the search is over. So until the search is over, so you have to tell, okay, until the search is over, low less than or equal to high, you have to do that. What? Get in the mid. Mid equal low plus high divide by 2. Low plus high divide by 2. And then you compare the mid value if this list data mid value is equal to the search value, then you can say return, you can say the item found or return the mid, return the mid value, or you can say the item found or that found status or found equal to anything. You can use elif. You can say the list data is less than the mid value, then you have to search the lower list. If list data is less than the value, then you are searching the lower list. So low equal to mid plus 1. Mid plus 1. Low equal to mid plus 1. Else, you can say, you can change the high value. High equal to mid minus 1. That means if the search item is less than value එකට වැඩි අඩු එකක් search කරනවා නම් ඒ කියන්නේ මේ වගේ දැන් search list එක තියෙනවා. Let me show this. Okay, you have the search list. Let's start the binary search again. We are searching for 500. Binary search. This is the low, this is the mid, and then the middle is taken. Okay, that is 15. Then search is 500. 500 less than, and if 500 is less than this 469, you are searching this one. Then on you have to change the less than. If it is less than the search value, you have to change the low value, that is mid plus 1. Okay, let's take okay, let's select something less than 469. I'm going to take 444, right? 444, which is less than. Binary search. Low value, high value, mid value is 15, and you can see then 444 is less than mid value. Then what will happen? Then you can see I'm changing the high value to 14. Here I'm changing the high value to 14. High equal mid minus 1. Else I'm changing the other part. That's all. Right? Because my value is lower than. So this is other way, right? If my value is lower than, what I have to change? I have to change the mid value. If my search value, that 444 is less than 447, then I'm changing the high value. High value is mid minus 1. Now current high is 40. Otherwise, I'm changing the low value. Low value is, then you can say mid plus 1, the 60. I'm searching the other part. So that's what I have to continue to do. And this is repeating. That is the nature. Okay, that is the algorithm. Now we have built the algorithm. And so let's, after everything, I can either return. So if it is found, it's returned in the mid value. No? If it is not found, at the end, I can say return minus 1. Minus 1 will be returned if it is not found. Let's do the binary search now for the same value. But before that, we have to sort the list. So let's sort the mark list. Marks.sort. I'm using the shortcut of sorting. After sorting, I'm just getting that and printing that result. This is a binary search, the other algorithm, and doing this and running this now. Okay, I'm searching 45 and sequential search 2 times. So what's here? List indices must be integer slicer, not float. So what has happened? Here. This should be converted to integer. It's my mistake. Should be converted to integer. That is not there in the 45. You can see search 2 times and true. True is coming from this second one. And the print results, the results is the founded item. So here actually the mid value. The third item is 45. Third item is 45. Is it correct? 45. Third item. So it's finding the other way, right? Make a math that I will. It's the third search. Return the mid. Actually, no, don't. So we can do something like this. Instead of returning the mid, you can return list data mid, right? If it is found, you can say list data mid value. Okay, searching 45 now. If it is found, then 45 will be returned. You can see the 45 will be returned. True and 45 will be returned. So the result is this. Okay, that is the binary search. In binary search also, you can indicate the number of search times. So that can be done again here, C equals 0. And each time you search, you can indicate C equals C plus 1. And finally, before this, you can say search this times. Before this, search C times. Let's run this now. And the first one says, first one in the 45, it says search 2 times. And here Before it returns here also I have to tell how many times it found. So let's run it. Again, searching for 45. Okay, search 3 times, search 2 times. Now you can see sequential search is faster. So let's search for some other item. Let's search for 90. 90 money. So let's search for 90. And 90, you can say 11 times. Sequential search 11 times, but binary search only took 4 times. So binary took is faster in searching. So when there are a lot of items, especially when your item is in the corner, the binary search will be faster. Right? That's what I want to teach. The binary search is faster than the normal sequential search. But if item found in the first page, item binary search will be faster. Let's search for 38 now. 78. 78. 6 times by the sequential search, 3 times by the binary search. You can see binary search will not go 11 times, 10 times. It will go 1 time, 2 times, 3 times, maximum 4 times. Okay, let's search for missing item. Nati item ekak search karam. I'm searching for 100. And 12 times here. Binary, so linear search try for 12 times. Binary search only try 4 times and returns -1, not found. So binary search maximum is 4 times. Log n. N is 12. Log n will be so around 4. Right. You can copy this, Pute. I'll stop from here. Please practice both. Right. Please practice both. This is essential. Until you understand, please practice this. Both functions. Oh, I'll send you the file. That will be easy, I think. So let me send you the file, then you can edit the file and see. When you are editing the file, right click and open with IDLE, right? Right click and open with IDLE. I'll send it. Okay, the documents. This is the file that I have tried. So I know this is a bit hard, but don't worry, you will not be asked to write code in Python normally. When it comes to this level, they will not ask to write the entire code. Instead of that, they will ask to fill in the blanks. Fill in the blanks. To understand the code or the fill in the blanks. That is what it's asking, right? I know this part is a bit complex. So this is the most difficult part in your syllabus related to Python, the sorting and searching. Sorting algorithms I'll be doing next week. So with that sorting algorithm part, our discussion will be over. Then I'll be starting the new lesson, right? Or we can discuss the questions and come to the new lesson. So that you have the choice, you have to choose. Tell me, then I'll do accordingly. Okay, please download the file. I'll stop from here, then see you all next week. Good night.
Thank you, sir. Good night.
Okay.
Thank you, sir.